Alright, so here we are, Chapter 4, still, Systems of Equations. 4.3b is this video. We're going to do another example. The first example was pretty straightforward, so let's go through the addition method. So, let's see, here's the addition method again. Here's the steps that we need to follow. The executive summary is, again, from page 291 in our book. Make sure both equations are in the same format. X's on the same side of the equation. Y's on the same side of the equation. Numbers on the same side of the equation. Usually it's X's and Y's on the left, numbers on the right, but it could be X's on the right, Y's on the right, numbers on the left. Could all be the same. That could be a valid way to proceed, but as long as they're both in the same format, meaning they're both in the same format with X's on the left, Y's on the left, and numbers on the right, something like that, you're okay to proceed. 2 is clear fractions if you have any. You can always work with the fractions as well. Step 3 is multiply one or both, and again this is the important part. Multiply one or both equations so that coefficients of one variable, x or y, in other words the number in front of the variable, is opposite or are opposite. So you can have in one equation 1x, in the other equation negative 1x. In another example might be if you have positive 3y in one equation and negative 3y in the other equation. That is, both coefficients are opposites, and then you can proceed. Step number 4 is add the modified equations, so that when you add up those equations, you'll eliminate one variable, the one variable with the opposite coefficients. And then 5, 6, 7, 8 are just like, those steps are just like in the substitution method, where the remaining equation has just one variable. Solve for the one variable, you'll have x equals a number or y equals a number, and then take that value back into one of the original equations, substitute that value in, and that results in an equation with just a one variable, and solve for that second variable, and then you've got your solutions that you can check. So there's our example from what we did before, and now here's another example. So in the previous example, in 4.3a, those two equations already had opposite coefficients. So that's not always the case, and in fact many times, probably often if not always, we'll have to multiply one or both equations, sometimes both equations, to get opposite coefficients for one of those variables so we can add them up and cancel. And I guess, by the way, does it matter which variable we cancel? Do we eliminate x's or do we eliminate y's? Probably whatever is easiest to eliminate, and that's just I guess getting used to it and having some experience as well. So here's our instructions. Instructions say solve this system using the addition method. Solve is the verb, so that's what it's telling us to do. We got to find an x and a y value from the addition method. All right, so let's take a look at the addition method. I got a red equation, 3x plus 5y equals 17. Certainly that's an equation. I got a green equation, 2x minus y equals negative 6. So our first step in, I guess from the executive summary says, well, make sure that they're both in the same format. In other words, x's in the red and x's in the green are on the left side of the equation. Sounds good. Y's in the red and y's in the green are on the left side of the equation. Sounds great. Numbers in the red and numbers in the green are both on the right side of the equation. Sounds great. So now that's in the same format. Clear fractions, we don't have to do that because there's no fractions there. Step number 3 is multiply one or both equations to get one of the pairs of numbers in front of the variables, coefficients, opposites. So right now I've got a positive 3 and a positive 2. I've got a positive 5 and a negative 1. Well, you know what? This one might be, this might be our way to attack this system of equations. In other words, multiply the green equation by positive 5. And if we do that, we would have a positive 5 here and a negative 5 there. And those would be opposites, so that when we add them up, we would eliminate that y variable. So let's try to do this. This is the way I recommend doing this. I'm going to say multiply by 5, so that when we multiply by 5, we move to the right, because it's just kind of cumbersome to move all this stuff down. I recommend moving things to the right if you've got some space. So by multiplying by 5, I mean multiply the entire equation by 5. So multiply the entire equation means multiply all the terms inside of it. 2x times 5 gives me 10x Negative 1y times 5 gives me negative 5y, and that's the reason that we multiplied the original equation, the green equation, by 5, so we could get a positive 5 here and a negative 5 there. And that's the reason. So now we continue and multiply our originally green equation by 5 equals negative 6 times 5, negative 30. And then we don't really need to multiply the red equation by anything. So we just simply say that this is 3x plus 5y, and it doesn't take much to rewrite this equation, equals 17. So now we've pretty much now multiplied by, this is step 3, multiplied by some coefficient, one or both equations. In this situation, it just turns out that we multiply one equation by 5, so that we can eliminate, so we can get the positive 5y in the red equation and the negative 5y in the green equation to be opposites. So then step 4 says add the modified equations. 3x plus 10x is 13x. Plus 5y minus 5y goes away. You could write a 0 down there, but I would not, only because it would kind of, it's clearer if you don't have that there. 17 minus 30, or 7 plus 17 plus a negative 30 is negative 13. So 13x equals negative 13, and we want just x, so we've got to divide by 13 each side, and we get x equals negative 13 divided by 13, negative 1. Now keep in mind we can't just stop there because it says solve. Solve means give me an x and a y. So if we've got x equals negative 1, we can go back up into here and choose either equation. I'm going to choose the green equation just because the 1y here is negative 1y, and it seems to be a little more straightforward, I guess. So 2x minus y equals negative 6, and I'm going to take that x equals negative 1 and just substitute it in right back up here. 2 times negative 1, oops, sorry, 2 times negative 1, let's make it a little clearer. 2 times negative 1 minus y equals negative 6, and all we did is just change that x for negative 1. Negative 2 minus y equals negative 6. Let's add 2 to this side and add 2 to that side. Negative y equals negative 4. Divide by negative 1, y equals positive 4, and it looks like we're done. I got a y value, I got an x value, they're both whole numbers, and probably in this type of situation we're going to have whole numbers, so it looks like a pretty decent solution. But yeah, now in order to really double check, we should just double check. Let's start with 3x plus 5y equals 17, substitute in x and y. 3 times negative 1 plus 5 times 4 equals 17 with a question mark. Negative 3 plus 20 equals question mark 17. 17 equals 17. Sure enough, that checks out. So let's go to the green equation, double check our work there. 2x minus y equals negative 6. 2 times negative 1 minus y, 4, equals negative 6 with a question mark, probably. Oops, sorry, that's a 4. Doesn't look like a 4, but it's a 4. Negative 2 minus 4 equals, with a question mark, negative 6. Negative 6 equals negative 6. It double checks. So there we go. We got all our points. We checked out the points. We did our work to get the x and the y value, and we double checked our work here to make sure that it works. Checks out, and there's our solution. X equals negative 1, y equals 4. You could put negative 1 comma 4 as your answer right over here and say, there's my answer. Give me credit for it. All right, next question is, we'll go to this one using the addition method. And you know what? I'm going to put this onto you guys and say, you know what? Do this for me. Show me in class what this would look like and what kind of solution you get. So I'm going to ask you also, bring it into class, and I guess what is your first thought? I guess my thought would be you could probably multiply the green equation by something to eliminate the x's. What would you multiply by? I would guess probably multiply by negative 4, because then you'd have a positive 4x and a negative 4x in the red equation and green equation, and you could add and eliminate. But I guess before we do that, you probably have to go through step 1, 2, or I guess 1 and 2 are both equations in the same format, looks like it, and clear fractions don't need to.